So for example, let's integrate root x squared plus y squared ds over the curve C, where C is parameterized by r of t is 2 cos t I plus 2 sine t j plus t k for t between 0 and 4 pi. So this is a helix going upwards of radius 2, which goes around twice. So first we'll find the velocity vector. So r prime of t will be negative 2 sine t times I plus 2 cos t times, that should be times j, and then plus k. So then the magnitude of this velocity vector will be root negative 2 sine squared plus 2 cos squared plus 1 squared, which is root 5, independently of the value of t. So now we can integrate. So our function was, maybe I should have left that there. So integral c root x squared plus y squared ds. So this will be integral 0 to 4 pi. So if r was equal to 2 cos t, 2 sine t, then this is the radius in the xy plane. So this will just be 2. So we're integrating 2 times root 5 dt, and this is a constant, so we get 8 pi root 5 as this integral. Now, on the other hand, let's evaluate the same integral, or the same function, rather ds, but where now c will be the straight line segment joining the origin, or sorry, not the origin, 2, 0, 0 to 2, 0, 4 pi. So the same starting and end points as our helix. So there's a simple parameterization of this. 2, 0, 4 pi t. So then the velocity vector here will just be 4 pi k. So, and this from t between 0 and 1. So this integral will be integral 0 to 1. Now the radius in the xy direction, I guess, is still just 2. The size of the velocity vector is 4 pi. So we get 8 pi. Now in our for the helix, though, we got the answer 8 pi root 5. So make an important observation, which is that if we have a curve joining 2 points, so if C is a curve joining a point A to a point B, then the value of this integral can change. Maybe I should say, in general, if we have a second curve, C prime, if we have two curves that go between the same points, the integral of f along them might not be the same. So the integral doesn't depend on a parameterization of C. Like many different parameterizations of the same curve will give the same answer, but different curves will give different answers. So it's not just dependent on the endpoints in general. And we'll explore in the later section when under what conditions this only depends on the endpoints.